Okay, so you can download the notes on arrays. They're up on eCentennial. And we're just going to introduce the topic today. I'll have to continue it on next week. So anything I cover today on arrays, it's possible to show up on the midterm. Okay, but next week I'm going to get a little bit more in depth into arrays, and that won't be on the midterm. But anything we cover today, it's possible. Okay. So far, what we've been dealing with are variables. Okay, single variables. So if I wanted to store a number, I could say int number equals 1. Okay, and now I have a variable that stores one value. Okay, but let's say, or for example, I could have a string called name, and I could make it equal to my name. Okay, but let's say I need to store a list of names. Right? Let's say I want to store all of your names in my program. Okay? You think it would be a good idea to do something like this? So say string name 1 equals Carmen Brange. String name 2 equals John Smith. String name 3 equals Bob Jones. String name. Is anyone going to stop me anytime soon? This is getting really boring. So do you think this is a good way to do it? Right? Remember when I said this was referring to loops before, but I said if you find yourself doing something really repetitive, there's a better way. The computer has a better way for you to do it. Okay? So this is not what we want to do. We don't want to do this. Okay? This would make it really, really hard to program. So what we have another sort of, now we're getting into data structures. Okay? We're sort of leaving pure variables and we're getting into data structures that store more than just a single number or a single string. Okay? So now what we're doing is we're learning about arrays. Okay? So an array is just a list of variables. Okay? So if I wanted to store all of your names in a structure, of an array might be an appropriate data structure. Okay. Now, one thing to know about arrays is that the data is stored contiguously. What does that mean? In memory. Yes. So, yeah. So in memory, you can think of memory as looking something like this, like a table. Okay. Zoom out. So imagine this is the memory in your computer. Okay? And each one of these little boxes here is a memory address. Okay? So the first one would be the 0th spot. Then it would be 1, 2, 3, 4, 5, 6, right? So we can address all of these memory locations, okay, in our program. So for example, when we declare a variable, let's say we say int number equals 10. So what we're doing is we're reserving a spot in memory somewhere, and we're putting 10 here. Okay? But now what we're doing is we're going to create an array. Okay? So the way we do that in C# is we use, it's almost the same. So let's say we're going to create an array. We're going to say int numbers, okay? And that's all we're going to do for now. Okay? But the other thing that we do is over here on int, we're going to put 2 square brackets in front of that, on the right side of that int. Okay? So what that's telling us is that this now is no longer just a variable. It's a list of ints. It's an array of ints. So it's a group of ints. Okay? And so what we can do now is we could, what we're going to do is we have to use the new keyword. okay, which we haven't used too much yet in C#. Actually, so what we want to do is we're going to say this integer, this array is going to equal a new array, and the way we say that is we say int again with the square brackets, and we're going to put a number inside the square brackets here. So what we're going to say is we're going to create an array with 5 spots in it. Okay? So what we've essentially done by just doing this, okay, is so this is our memory now, and so what we've done is we've reserved 5 spots in memory. Why can't I? Oh, I gotta do. Let's change the background. Borders and shading. Okay, so we've reserved these spots now. This spot for memory for stuff that we're gonna stick in here. Okay, and so what we can do now is we can access each one of these little spots in memory. Okay, and the way we do that is we'll say numbers, so we reference it just like we reference other variables, but now we're going to use our square brackets, okay, and our semicolon. Okay, now here's the thing, our list, the count starts at 0. Okay, so what that means is, so I've created a label called numbers, and what it's pointing right here. It's pointing at the start of this position. Okay, so what we're saying when I say numbers 0, and then I could say equals 15, for example. Okay, so what I'm saying is I'm saying go to the area in memory that I'm pointing to with this label, which is right here. And then it's saying from that location, move over 0 spots. So that's going to put us right here. Okay? So what this command is doing is it's saying, okay, put the value 15 in that spot. Okay? Now if I do this, let's go one line down and say numbers 1 equals 20. What's that going to do now? This one here? What's it going to put? 20. Okay? Now what if I do this? What if I say number 4 equals 30? What's going to happen now? The last box, this one here, right? What's going to be put there? 30. So why, but this is the 5th one. Why is 4? It starts from 0, right? So when we say number, it's starting here, and it says from here, move over 4 spots. 1, 2, 3, 4. Boom, there we go. Okay? Now what if I said this? What if I said label 1 dot text equals number 4? What should go in? 30, right? Okay, so notice how, see the memory here. So let's fill out the rest of this. Let's say number 2 equals 21, number 3 equals 22. Okay, so this would be 21 and 22. So notice how all of these numbers are right beside each other in memory. Okay, there are other data structures that we won't get into in this class where you don't need to store everything right next to each other. But we're not going to talk about that in this class. So for now, this is probably our first and only data structure that we're going to learn about, other than maybe we're going to talk about objects a little bit more. But with arrays, the data is stored contiguously. So that means it's right next to each other. Now here's the other rule about arrays. each item in the array has to be of the same type. So could I do this? Is that going to work? No. That's not going to work. Every item in my array, so in here in memory and here in my code, has to be the type that I created. And they all have to be the same type. Okay? Okay. So let's go to some actual code now. So I'll save this. Okay. So let's open up Visual Studio. And so we'll stick with this project that we've been working on so far. Okay. So let's go to our form. And let's move our label up here, just because. Okay. Now, in our button handling method, okay, we're going to declare an array. Okay. So we're going to say int, and then we have to put our little square brackets. Okay. Int, and we're going to call it my first array. Okay. And then we're going to set it to equal a new int. Okay? And we're going to put 20 slots into our array. Okay? So now this is a list of arrays that can hold how many integers? 20 integers. Okay? This fell over my chair here. Okay. Hex key. Does anyone have a hex key on them? It is a little tiny bit out of focus. Okay, so now there are a couple of ways we can. So let's go back now to our demo here. So what we've done now is we've taken 1, 2, 3. How many cells do we have here? I think there's about 10. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, 10. So we've taken 10 of these cells, and now we've saved them. We're saying, okay, we're gonna in the near future, we're going to store some data here. So we are reserving these spots in memory. Okay, and each one of these slots is big enough to hold an integer value. Okay, so that's what we've done now. So now let's go back here and let's start initializing some of the values. So there are a couple of ways of doing it, but one way is we can say my first array, and then we use the square brackets, and then we can put the number of the slot, the index, inside the square bracket. So let's say I want to set the first slot. I want to set the value. So what number do I put inside the square brackets? 0, right? Always remember, arrays start counting at 0. Okay? So we put 0 in here. And now this is just like any other integer variable. Okay? So now we just treat it like a variable, and we'll say equals, let's put 10 in there for now. Okay? So now, so let me comment out this for loop here. So if I say label1 dot text equals my first array 0, and then I have to convert it to a string, what's that going to print in my label? 10. Okay, so I click there, and oh, there's 10. Okay, let's initialize some more. So let's copy this. I'm going to copy and paste this a couple of times here. Okay, and then I'm going to set this to be 1, 2, 3, 4, 5, 6, 7, 8. Let's make it 10. 9, 10. And so let's make this 11, 12, 13, 14, 15, 18, 19, 20. Okay? Does everybody have that? Okay, everybody caught up? So, what if I change this index from 0 and I change it to 6? What will print now? What will print? 16. Here we go. Now we can debug and we can inspect our array. Let's do that. So I'm putting a breakpoint right here. Okay? And so my code's going to stop now right here when I run. So I'm going to run it. And now I'm going to click my button. And so the code is stopped here. I can hover over my array and see I can click this plus button and I can see all the values inside my array. So see how there's 20 slots there? And the first 10 go from 10 to 20. Okay? Okay. Now, here's the million-dollar question. Well, I'll give you a statement and then a question. So the beautiful thing about arrays is that you can use loops to iterate through them. Okay? So if we want to what if I had an array that was 2,000 slots long? Am I going to be able to, should I be going through and accessing each individual array index like this if I have 2,000 indices? No. So, okay, here's the million-dollar question. We've learned about 2 types of loops so far. What types of loops have we learned about? For loop and a while loop. So which one of those should we use to iterate through a for loop? sorry. I just gave you the answer. Which one of those loops should you use to iterate through an array? A for loop. Why? Why a for loop? We know how many times we want to loop. Why do we know that? Yeah, we know the size of our array. Okay, so let's do this. Let's comment out this stuff. Instead of doing this is the long way. Let's set up a for loop now. Okay, so how do we do a for loop again? So we put the keyword for, and then we have our brackets and our braces. Okay, I always like to do that first. Then inside our parentheses, we're going to give it an integer that we're going to start at 0. Okay. And then we're going to say while I is less than, and now we could, because we know the value here, we could just put 2000. Okay? But actually, remember, arrays are an object that come with many properties and methods. And one of those properties is the length. Okay? So now what I can say is, so this is saying keep looping while I is less than my first array dot length. So what is the value of my first array dot length? No, 2000. Because even though the indices go from 0 to 199, there's still 2,000 elements, right? It's counted. Yeah, exactly. So we start our for loop on 0, and we go until we hit the length. Okay, and then we're going to say I plus plus. Okay. Now inside our array, so let's initialize our array values. Okay, we're going to initialize 2,000 array values using our loop. So what we're going to say is we're going to say my first array, and then what are we going to put inside our square brackets? Length? Okay, so you say length and you say I. What will happen if we put length in there? Yeah, I. Because if we put length, it's just going to keep overriding the very last thing over and over and over again. But if we put I inside our square brackets, I is going to change every time it goes through the loop. I is going to be 0, 1, 2, 3, all the way to 1,199. Okay? So now let's make the value of each of those slots, let's set it to be I. Okay? So now let's run it. So what's going to be stored inside our array? Let's see. Let's run it. So we'll stop it and we'll start it again. And it's going to break down here again. Okay, so we're going to click this, and now so we have our breakpoint, and now let's inspect our array. So we'll go over here. So see, it shows us it has 2,000 indices. Okay, so if we click our plus, now look, we can see all of the values have been initialized. Okay, all the way up to 2,000. Okay, imagine if we had to type that out. My first array 11 equals 11. My first array 12 equals 12. Right? You'd get carpal tunnel syndrome. Your hands would seize from all the typing you have to do. Okay? But what we've done is we've saved ourselves from doing that, and we've used a loop to process our array. Okay? So now let's do, how would we, let's print all the values in the array to our label. So how might we do that? What are we going to have to do now? Label, okay, label 1 dot text, okay. Equals what? Okay, equals my first array. Whoops. Square bracket. I, okay. ToString, okay. What's that? What am I forgetting here? I need something around this. I need my for loop. Because in order to get all the data out of my array now, I have to loop through it. So what I have to do is I have to create another for loop. Right? For int I. What am I going to set I to be? Because I want to iterate through all 0, exactly. All the values in my array. Okay? And then I'm going to loop while I is less than what? Sorry? Yes, exactly. My first array dot length. Okay? And then I'm going to increment I by 1 each time. Okay? So now I have this this for loop. Is this going to be enough? Yeah, more or less. Let's see. Oh, actually, we have to add this in here. Otherwise, we're just going to have 2,000 in there. Okay? And then also, let's put a space between each of the letters, each of the indices. Okay? And let's run it. Oh, it's going to take a second. What did we do here? Oh, it's almost there. So see, it actually took some time. So now when we come on. Oh, it is running. Okay. I don't want Camtasia Studio. Okay, so now when we run it, we should have. Oh, no! See what I've done here is at the end I've then clobbered everything in my label. So let's stop it. I'm going to comment out this. So the only thing I have in my button click event now, is so I define the array. Then I initialize the values, and then I'm printing them to the text box, to the label. Okay, let's try it. Let's press it. So now it's going to take a little bit because it has to do something 2,000 times. Okay, and probably there's a more efficient way to do this, and I'll show you how to do that in a second. It's almost done. What's going on here? Where are we? Okay, let's just look here for a second. Why is this not working? Let's try it again. Or let's do this. Instead of writing directly to the label, what we're going to do is we're going to create another string called temp, and we're going to make it an empty string. And then instead of concatenating to the label, we're going to concatenate to temp. So we're going to say temp equals temp plus the rest of our array that we're turning into a string. And then just at the end, we're going to say label1.text equals temp. Okay, and let's run it and see what happens now. Let's stop. Actually, let's debug it. We're going to figure out what's going on here. Okay, so it's working correctly. But why? I suppose it doesn't like my label. maybe I'm probably putting too much text inside my label. So what I'm going to do is we're actually going to create a text box, and we're going to click on our text box, and we're going to set it to be multi-line, because we're going to go into the properties window, and we're going to select multi-line. We're going to make that true, and then we're going to expand this. Okay. And then what I'm going to do is I'm going to go back to my button, and I'm going to change from label. I'm going to say text box 1 text equals temp. Let's see if that works now. There we go. Okay. All these numbers that were stored in our array. Okay. So let me know if that's where I'm going to end today as far as lecture. But let me know if you're getting that. Let me see what you got. Oh, so you need to say here, you need to tell it what type of. And then there. So yeah, see what I've done there is instead of working directly in the text box, what I did was I created a string, an empty string, and then I concatenated it to the string, and then I put the whole string, I just dumped it into the text box. That'll be a lot faster, because every time you access something on the UI, it takes a while, a couple of milliseconds, which is ages from looking at it from the computer's perspective, right? So we want to interact with the UI as little as possible, right? So first we go through the loop, and then we just dump all the text into our UI. Okay. Okay, I'm just going to run to the bathroom. You guys just work on that. We have about 2 more minutes, and then we're going to be at the end of class. Okay, folks, so that's the end of class today. I'm going. Okay, does everyone have their form project up and running? Okay, so does everyone have a button and a text box that they're making multi-line? Okay, and we'll turn on scroll bars for vertical. Okay. And we'll change our button text to start. Okay. Who doesn't have that? Does everybody have that? Okay, so let's do a quick recap of what we've done up until now. Okay, so we started off the course talking about variables, right? Okay. So what are some types of variables that we learned about that we've used so far? Yep. String, right? My string we can make it equal to a string value. So anything can go in here. What else did we learn about? Integers. And so we can make integers equal a whole value, positive and negative, right? We also learned about doubles and floats, which hold decimal numbers. Okay. Oops. Okay. Sorry? Char? Sure. We didn't really spend a lot of time on char, but char will hold a single character. Okay. Any other types of variables that we learned about? What? Array? No, that's coming. That's what we're doing today. Okay. So let's print all these values. So how do we do that again? So we have a multi-line text box called textbox1. Okay, and I have my button click handler. If I double click on my button, I go to my button click handler. So I wanna put the values of all of these variables into that text box. So how do I do that? Text box 1 dot append. Okay, and then we can do my string. Okay, and so if I run that, we get our string appears in here. Okay. Now, what if we want a new line after that? What do we have to do? Yeah, we have to put in a new line character. Okay. So we won't see it now because there isn't a new line. But let's go to the next line now. So let's put in the integer. So what do I have to do to my integer variable in order to print it to my text box? Yeah, I have to convert it to a string, right? And I'll do the same thing I did up here, is I'll put in a new line character. Okay? There we go. And let's do the same thing, so I'll copy and paste this line. Copy, paste, and now we'll get number 2, and that should be the same thing. We can still use this toString function, and then we'll do one more, which will be we'll append the my char, and I don't think we need to convert that, but let's just see. Okay. So now, let's say I want to display an error message if number is less than 0. How would I do that? What structure would I use to do that? If, right? So I would say if number less than 0, okay, then what will alert? Message box show value less than 0. Okay. So now if I run this, so now we get a message box up. So what will that message box appear if I change this to be 200? Or even 2? No, because this will only run if it's less than 0, and 2 is not less than 0. Okay, so no message comes up. Okay, we could also use an else. So if it's not less than 0, then what are the other options? If it's not less than, what could it possibly be? Greater than, but what else? Equal to. Okay. So now if I so now it's 2. What's it going to print out now? Yeah, it's going to print out this one, because if this is false, it's going to do this command. Okay. There we go. Okay. Okay. Now, what if I want to? So I want to append 500 copies of my string into text box. What would I use to do that? Should I do this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should I do that? 11, 12, 13, 14, 15, 16, 17. Is that a good idea? Anyone? No. So what should I do instead of doing this? A loop. So how do I do a loop? What loop should I use? I know I want a loop for 500 times. What kind of loop should I use? A for loop, right? So remember, a for loop, we use the keyword for, okay? And then inside the loop, we're going to give it our counter variable. Okay, guys, please try and come on time, okay? Okay, so our counter variable is going to be equal to 0, and the counter variable is going to be called I, and we separated it with a semicolon. Then the next portion is the condition of which this loop will keep running while this condition is true. So we're going to say while I is less than 500. And then the third part of the for loop tells us what we're going to do to I for every iteration of the loop. Okay? And then inside, the part that we want to loop, we put inside these curly braces. Okay? Okay? So now what should happen is now we get 500 copies of anything can go in here, right, in our text box. Okay? Okay, now how could I do this same thing but using a while loop? How could I do that? What would I type? Sorry? So I need a variable? Well, what kind of variable? An integer? Okay. What should I call it? Counter? Okay. Equals 0. Good. Now what? While. While what? Counter less than 500. And then I put this in here. Now what else am I missing now? I'm still missing one thing. Sorry? Counter plus plus. Right? Which is the same thing as doing this. It increments counter by 1. Okay? So let's see it now. And actually, let's do this. We will concatenate the counter variable so that we can see what the number is. Okay? So we're going to print my string and then concatenate the string version of counter, and then we're going to concatenate a new line as well. Okay? So let's run it. Here we go. Okay. Okay. So if that wasn't very, very easy for you, and it wasn't complete review, then you need to study hard for the midterm. Okay, because you're going to have difficulty. If that was a challenge, if any part of that you were lost or just, not really comfortable, then you have a problem that you need to fix before next week. Okay? That means you need to study very hard. You need to go get tutoring, a couple of sessions before the test. Right? You need to redo your labs so that you understand them. Okay? Okay, because the test is next week. Okay. So what we're going to do today is we're going to reintroduce arrays. And we're going to start getting into some sophisticated algorithms. Okay, we're going to start looking at more than just simple looping or simple decisions. We're going to start making algorithms that are actually doing something useful. Okay, so I think we're going to start with some sorting algorithms. Okay, and we'll see how far we can get. What's that?
Search and sort?
Exactly. Yeah.
Such as linear search, something like that?
Yeah, we're going to look at a couple of sort methods. Yep. Okay. So does anyone remember how to... So first of all, can someone explain to me what an array is? What's an array?
It's a list.
Oh, one at a time. Sorry? Go ahead.
It's a collection of items inside.
Yep. Okay, anything else? So an array is a list of variables, essentially, right? Can you have more than one type in an array? Can you have two types of data in an array? No, you can't. Okay. Is the data stored in memory? Are all the slots right beside each other, or are they spread out throughout memory? You have a problem? Okay, what's the issue? What's that? Oh, because you have capital T, and the value of the text box is lowercase t. Okay, and here you say capital T. Okay? Okay, so remember, so let's clear all this out. Let's comment this out. Okay, get rid of this code. And we'll start fresh with an array. Okay? So remember, the way we define an array is it's almost identical to how we create a variable, right? So we give it a type, and in this case we're going to call it myArray. Okay? And we just have to add one more thing. So on the type declaration, what we're going to do is put square brackets around it. So now we're telling C#, instead of just having one integer variable called myArray, I want a whole list of integer variables stored in one thing, one label, one reference. Okay? And then the way we actually, so this is only, what we've done here is we've created just like a pointer or a reference, right? It's just the same as if we did this, int number, right? At this point, none of these have any values. All we've done is we've sort of prepared C#. We're saying, okay, eventually we're going to have a number, and this one says, okay, eventually we're going to have an array. So what we have to do is we actually have to create the array using the new keyword. Okay? So then we have to give it the type, and then we use the square brackets again. And what are we going to put inside the square brackets? We're going to put a number. What does that number represent? Yeah, the number of indices that we can have in our array, right? So let's start with 20, like this. Okay? Equals? Equals new int 20. The 20 is in the box. It is. So now let's debug this. So I'm going to put a breakpoint here by clicking here, and I'm going to run it. And when I click here, it should stop here. And so right now it's null. But if I go down to the next value, okay, and I go back up here and I inspect my array, so now notice there's a plus here. There's a plus button, and look, so now I have 20 empty slots in my array that I can put things in. Okay? So if I do this, what I can do is I can stop the code. So I'll say something. Now we can reference each indice, each slot in the array by saying myArray, okay, and then using the square brackets, and inside the brackets we're going to tell it which slot we want to reference. Okay? Now when you're counting the slots or indices, what number does it start at? 0. Remember that, okay? So essentially what this means is this is the offset. Okay? So you're saying I'm pointing to an array of integers, and I want you to move over 6 integers from the starting point of that list. That's what this is saying. Okay? So what we can do now is we can put a value in here. So we could put in 33, for example. So now let's debug again. We'll go here, and let's run it and debug and see what happens now. Okay. So now if we inspect our array, notice that the 6th slot, or the 7th, 1, 2, 3, 4, 5, 6, 7, it's labeled 6, but it's actually the 7th. Notice the value is now 33, right? Because we've changed that value here. Okay? So is everyone understanding that thus far?
So we wrote myArray in square 6.
Yep.
Equals 33.
Yep.
And here it's showing an error.
An error?
Yeah, it's showing like red text under myArray.
Okay. Now you have 33 is stored in 6. Okay? So if you change this to 5, slot 5 would be 33. Okay. Let's see here. Okay. Let's do, so what type of loop? So usually loops and arrays go hand in hand. Okay, it's like cars and gasoline. You know, one is not good without the other. Okay, so what type of loop do you think we should use if we're dealing with arrays? Should we use a for loop or should we use a while loop? A for loop? Why a for loop?
Because we know how much numbers we have.
Yeah, how many times we want to loop. Essentially, usually we do, right? Like so for a while loop, let's say for example we were waiting. You might want to use a while, like you use a while loop when you don't know how many times you're going to loop. So let's say I'm accepting user input, and it needs to be in a certain format. Well, I have no idea how dumb the user is going to be. I don't know how many times it's going to take them to try it again, right? So I'd put inside a while loop, I'd say accept user input, check user input, if incorrect, then keep looping, right? And so in that sense, it could go on forever. But with when we're dealing with an array, we usually know about how many times we want to loop through the array. Okay? So what we can do is we'll use a for loop to manipulate our arrays. Okay? So what we're going to do is we're going to use a for loop, right? Remember, then we give it our counter variable, and we're going to set it to equal 0. Okay? And then we're going to make it continue looping while I is less than my array. And what we're going to do is we're going to use a property of my array called length. So length will tell us, is it a method or a property? I think it's a property. So length will tell us how many indices or slots we have in our array, right? So we could do this. We could do this, but why is this not as good an idea as this? Yeah. Yeah. So let's say I do this. So it's correct now, but what if later on I say, oh, actually I need my array to have 30, right? Now this is incorrect. But if I do this, this will always be correct, no matter what I set this to be, because it just uses the length, whatever it happens to be at that point. Okay? And now I'm also going to increase I by 1 for every iteration. Okay? So now what I want to do is I want to set I want to put a value in every indice, in every slot of the array. So how would I do that using this for loop? How would I do that? First of all, how would I access just one? How would I access the first? How would I set the first element to be equal to some value? My array, yeah, 0 equals 99. Exactly. So now if I do this, all it's going to do, what's it going to do? It's going to set 99. It's going to set the first slot to be 99 20 times. It's going to keep overriding it. Okay? So how do I get it to, for each loop, put it into a different slot? How do I do that?
Use an I instead.
Yeah, put I here. Right? So now every time we loop through, let's debug it and let's check it out. So we'll start our program. We will run our loop. So now we've come into here. Okay, so I is equal to 0. Okay. So now we can loop through our array. Okay. So the first time we go through the array, I is equal to 0. So what that's going to do, so all these, well, we already 6 is set to 33 because we did that up here. But so now I0 right now is equal to 0. But now after we run this line, now this slot, so 0, the first slot is equal to 99. Okay? Now I'm going to go around. What's I going to be equal now? 1. Okay? So now it's like the 1 is here. Okay? And if we look here, so currently 1 is set to 0. If we run this line, now it's set to 99. Okay? So let's let it rip, and we'll stop down here and see what our array is filled with. So we'll go here and we'll inspect our array, and now look, all the slots are filled with 99. Okay? Okay. Okay, let's do something. Let's create a search algorithm. Okay? We want to create an algorithm, a little bit of programming, that will search for a value in our array. Okay? And we just wanted to tell us yes or no. Does this exist or does it not exist? Okay? So, first of all, let's, what I'm going to do is, I'm going to, what should we do here? Let's just, for now, what I'm going to do is I'm just going to set this to be equal to I. So what effect will that have? What will be stored in this array? 0 to 19. Okay, let's try it. Okay, 0 to 19 is in here. Okay, so let's do this. Let's create. So from here to here, in this little area here, what we want to do now is create a function that will search through our array and tell us if a certain value exists in there. Okay? So how might we go about doing that? What sort of structures do we need to use to do that? What sort of programming concepts and elements do we need to use? A for loop. Okay, why do we need a for loop? Yeah, we need to visit each index in the array, right? So we're going to create a for loop, and we'll say int I equals 0 again, and well, I is less than what? Length of my array, right? Dot length. Okay, I plus plus. Okay, now so what should I put inside here? So let's say I have an integer value called value to find. Okay, and I'm going to set that to be 43. Okay, so this is the value that we want to find. So what do we put inside this for loop now? An if statement. Okay, so what should we put in our if statement? If my array, yep, I, yep, equals value to find. Okay, good. Then what?
Return true, I think.
Return true?
Return the index. Sorry. Return the index.
Well, so all we want to do is we want this should tell us if the value exists in the array.
Or set the text box the same way this is.
Yeah, something like that. Okay. So what should I put inside here? Yeah. So maybe I'll say text box 1 dot append text dot value was found. Okay. Let's try it. Okay. So let's run it. So should we have? But we also want it to tell us if it wasn't found.
Or
So else?
Yes.
Are you sure?
Yep.
Right here? After the loop. So why can't I put it right here? What will happen if I put it right here?
It will keep repeating itself.
Yeah, it's going to tell me 20 times value not found. I just want to know if once. Just tell me once. So where do I have to stick this?
Outside.
Outside? Oh,
Right. You have to instead of using else, you could say if it's not found and it reaches the last index.
Okay, how do I do that?
If I equal my array,
if I equals my array dot length, okay. What? Then what?
And we need to equals some flag into the
My
first
array
if.
my array I is not equal to value, not equal to value.
In here?
No, no, the condition.
Where? In here? So what should I put? And? And what? Yeah. Is not equal to value to find? Okay. Is that going to work?
No, because we need not if, else if. If we use.
Possibly. We're dancing around the solution. You guys, these are good. You guys are coming up with good ideas. So far, none of them will work, but that's fine. That's fine. We're working through the process. Okay, so keep going. Keep going. What else? You guys are thinking about algorithms now. This is the real meat of programming. Okay, this is what people will pay you for. Okay, it's not learning the syntax. The syntax we've been learning up until now, that's easy. Okay, once you've learned it in C#, you can apply it to Java, to C++, to PHP, to JavaScript, all these languages. What the skill is what we're doing right now, is creating the algorithm. Okay, so because why is this not going to work? Because it's always going to get to 20. It's always going to get to the end, and usually it won't be the value, right? So this is always going to come up, pretty much. So if we do this, we'll say value was not found. So let's run it. Okay, and let's put in. So let's put in 5, so we know the value should be there. Okay, and we'll run it now. So value was found. Why didn't it do the last one?
Professor Reggie.
Yeah.
One way, in case something is found like very early in the index, you could try to break a loop.
That is absolutely true. That is one thing we can do. Yep. I just want to figure out why this isn't working. Oh, because the length is 20, but there is no 20 indice, right? The highest indice is 19. So we have to do -1 if we really wanted that to behave how we think it should. So now if we run it, it's going to tell us both things. Okay? So one thing that was suggested is that because I only want the algorithm to tell us whether it was found or not, right? Not to tell me if there's more than one. What we can do is right after it was found, so we're going to make this algorithm a little more efficient. We're going to use a keyword called break, which I haven't shown you yet. But what break does is it kicks you out of the loop that you're in. Okay? Like prematurely. So even if we haven't got to the end of the loop, to this condition, if it hits break, it'll pop out of here. Okay? Because if we found the value and all we want to know is if there's no reason to keep searching, right? So let's get rid of this here because this isn't going to work. Okay? So this will work in the case that it was found. Okay? But now if we put here, we want a message telling us no, nothing was found. Okay? So any kind of ideas before I kind of show you the solution that I would probably pick? Let's try and work through this a little bit more.
Maybe we can just in the end just text box dot append text value was found, because if it was found, we don't get to the break.
Okay, but where would we put that?
After if statement.
After the if statement?
Yes.
But that's then, okay, if we do that, every time it checks, it's going to put that in. Because it's looping 20 times, so it's going to put that value in 20 times.
Oh, yes.
Right?
Yeah.
Okay, so what we need to do is, so these were all good ideas so far. What we need is, we need a flag. We need another variable to keep track of if we found it. So we're going to create a Boolean variable using the keyword bool, and we're going to call it found. and we're going to make this to equal false to start off. Okay? And then here, before the break, what we'll do is we'll say found equals what? Well, true. True. We can actually say true. Okay? And then here, what are we going to put after the for loop? Yes, if not found. So I could do that, or I could say, so that negates. So if found is true, the exclamation mark will switch it to false. Or I could do this. If found not equal to true. Either way is fine. Okay? Then we're going to put the text in. Okay? Now let's run it. Let's see what happens. Value is not found. Okay? So let's change it now. Let's change it to 15. Value is found. Okay? Okay, I'll let you guys chew on that for a second. Does everyone have that?
So after it's if found not equal to true?
Yes. So if not, basically if you went through the array and at no point was anything found, then tell us that. Oh, I forgot about my coffee. It's probably cold now.
Was it repeating?
Yes, it's still repeating.
Oh, okay. Probably because your if not found is inside the loop. Yeah. So put it outside the for loop. Is that what was that?
Yeah.
What other type of search, like binary search, for instance?
Yes, we could do that, but I'm going to keep things simple today. But binary search depends on it being sorted. So we're going to look at a sorting algorithm next.
I once saw this video last year, and then I remember this video last year that there was a sorting algorithm of showing, like, you know how they compare like an algorithm bubble, what do you call it, bubble sort?
Yeah.
Yeah. So pretend there was this two poles, right? Or two blocks, and then you sort them. Okay, is this bigger than this?
Yeah.
If yes, then switch it. If
Yeah.
not, then until it goes like that. So it goes in order, and then
Yep, that's what we're going to look at in a minute.
I saw that video, and it was pretty cool. And then it was pretty funny in the end that the bubble sort lost badly by
Yeah.
a lot of seconds, by
Yeah.
almost a minute.
Yeah, it's a slow algorithm. Yeah. Okay. But it is, 5 is in there. So put 99. Because remember, look, we populated the array here. So we went through, and so that would be 0 equals 0, 1 equals 1. So the number 0 through 19. So let's try 99. Should. Great. Oh, so because you have it in the text changed event handler. You want this in here. There you go. Okay. So let's change our algorithm a little bit now. Let's make it so instead of telling us just if it exists or not, I want the algorithm to tell us how many instances of that value exist in the array. Okay, so how might I do that? How might I change this so that it tells us how many exist rather than just telling us yes or no? How would I change this?
Make a variable of how many counts.
Sure. So int count, and we'll start off with 0. Now what do I do with count?
Every time it's found, you plus it.
Okay, where? Where do I do that?
Before the break.
Before the break? Okay. So count plus plus. Do I need to do anything with the break? Yes. Why do I need to delete it?
Because you'll be searching it more than once.
Yeah, I need to search through the whole list. Okay. What else do I need to do? Do I still want this line here?
Remove the text because you don't want to say found like what time you don't want to say it.
Yeah. So I'll get rid of this. Okay. And then what else? What else should I do?
In the end, put how many times it was found, so you can remove the if not found.
If not, but I still want it to tell us if it wasn't found at all.
You say 0. It would say 0. It was found 0 times.
Okay. That'll work. So you want me to get rid of this?
Yeah.
Okay. And
Well, what you could do is change the text box that the value was found something times based on how many counts.
okay. So what do I type?
Plus.
So what do I type?
Value was not found, and then was found.
But tell me exact. What do I have to? What?
Text box dot append text.
Text box 1 dot append text. Yep.
Then brackets. Quote. Value was not found. Quote. Then plus count toString. Bracket.
Value is not found. Are you sure?
Oh wait, no. Value was found. Quote. And then plus count toString.
Don't think you have to. It'll do it automatically.
Plus count times plus times.
Okay. Okay. So now let's do this instead of let's do this. So we'll get rid of this, which populates our array, and we'll say my array 0 equals 3, and then we'll copy this a bunch of times. Okay, so I'll make this 7, and this 2, and this 1, and this 8, and this 9, and this 9. You can make these any value you want.
Or what we could do is use a random, right? Use random
Yeah.
and then randomize it from 1 to 4, make a loop to append.
Yep, we could do that.
Rather
We
than
could
just
do
writing
that.
like 20 lines here.
Yep, we could do that. But I don't want to introduce too many things all at once. Okay, so now let's do a search. So now we have our array with some sort of randomized values, and let's search for 3. Okay? Value is found 4 times. Okay, let's confirm. Let's confirm that it's working. 1, 2, 3, 4. Seems to be working to me. Let's try 0. Value is found 1 time. Seems like that's correct. Okay? Yes, that was correct. Okay. Yep. Question? Yep. Okay. Oh, 3, is that what you... Okay. Oh, because here you override everything. See, because here you're setting the values, but now we're going back through the array, setting it to be 0 through 19. Okay? So if you delete this, then okay. So, okay. So now what we're going to do, we're going to try another type of algorithm. Okay. We're going to, now although C# provides you with some functions to just do this automatically, but I want to reinvent the wheel with you guys just so you can see exactly what's going on. Okay? So we're going to look at something called bubble sort. Okay. So bubble sort is a simple sorting algorithm, okay, that will put all of these values in order. Okay. So the way it works, well, let me put it out to you guys. Let's think about an algorithm, how we might sort this. Okay, so we have an array of 20 with some random integers. Okay, and so what we want to sort this array. So what are you guys thinking as far as structures? What are we going to be using to sort this array? Okay, a for loop. Yep. So we're going to need a for loop, at least one, right? Because we're going to need to iterate through the array at least once. Okay. So then we say for int I equals 0. Okay. Well, I is less than my array dot length. Okay. Well, and then I plus plus. Okay. So what I could do is, so what we could do is we could say this. We could say my array I, okay, or we'll use an if statement. we'll say if my array, so we want to order this array from lowest to highest. So 0 should be here and 9 should be at the bottom. Okay? So, for example, is this number, are these two numbers, are they in the correct order? Just given these two numbers, not considering the rest of the list. Are these two in proper order, given how we want to sort? Are they? Yes. Because we want lowest to be above. Okay? So we would not switch these positions. They're in the right order. Okay? Now let's look at the next pair. Are these guys in the right order? No, right? 2 should be less than 7. So what we should do in our algorithm should switch the pairs. Swap them. Okay? So how do we do that? Let's go back to our sorting algorithm. So what we'll say is, we'll say if my array I is greater than, well, we want to say I plus 1. Because if we do I minus 1 on 0, we'll try and access the negative 1 index, which doesn't exist. And we also want to go less than, we want to go less than, at least 1 less than the length. Because we only want to go up until 18. Because we're going to look at 18 plus the next one, right? And then, but that's the end. There's nothing to compare the final value to, right? So we're going to say if my array, right? So we want to say if this one here is greater than this one here, then switch them, okay? Plus 1, okay? Then what do we have to do? Can we say my array I equals my array I plus 1? Will that work? Yeah, because we're going to override whatever was stored in here. So first, what we need is we need a temporary variable. So we'll call it int temp, and we'll set it to be 0, and we'll put it outside of our for loop. Okay? So then what we'll say is we'll say temp equals my array. So we're going to temporarily store that value in there. Then we're going to set my array I plus 1 to, or for my array I to equal my array plus 1. And then what's the final step? Equals temp. Exactly. So now we've shuffled out the variables, right? We had two variables. Right? We had temp and then we had 1 and 2, right? So temp equals nothing, 0, and then 1, let's say equaled 5, and this equaled 2. So first we set temp to equal 5, then we clobber this value with 2, and then we set this value to equal this temp. And now we've switched them out. Okay, but we needed an intermediary variable to hold that value while we switch them. Okay? So is that going to sort the array? Is that going to sort everything? Let's run it. Let's see what happens. So we'll debug here. We'll see what the order of the array is. Let's inspect. So it's how we typed it in, right? It looks random. Okay? So let's now debug after our sorting algorithm down here. So this is our sorting algorithm. Okay, and we're going to continue. So let's inspect the array now. So it's still not really sorted. It looks a little better, right? Some of the values have been adjusted, but we still need to do something else. So any suggestions about what we might do? So what we're going to do is we're going to put a loop inside a loop. Okay? So what that will effectively do is so you'll be having multiple passes over the array. Okay. So what this does is this just went through the array once. It looked at all the pairs and switched them out if they were higher. But we need to do that over and over and over again. Okay. If we keep switching them out, eventually we'll have a list that is in the correct order. Okay. So what we need to do is around the outside. So we're going to create another for loop, and we're going to call the variable, we're going to call it j. Okay, and j is going to be equal to 0. Okay, and we're going to keep running this loop until j is less than myArray.length. Okay, and we're going to increment j every time we go through the loop. Okay, so now we have a for loop inside a for loop. So how many times will this inner for loop be executed, given that this is set to loop 20 times and this is set to loop 20 times? Why do you say 400? 20 times 20. Yeah. Because remember, this group inside this block here will run 20 times. And every time it runs, this will run 20 times. So 20 times 20 is 400 times. Okay? So this will loop through the array 400 times. Okay? So now let's try it. I think that's all we need to do. Let's try it. So our array is unordered. Okay, and now let's continue, and let's see what our algorithm did. There we go. Look at that. Ooh, nice and ordered. Okay, so let's step through this. We're not going to step through 400 times, but we'll step through a couple of times to see what happens. Okay, so let's go in here. Okay. So we're going to continue on. So right now our array, so let's inspect our array. I'm going to put a window over here. Let's do this. And I'm going to, so this is our array here. We can see our values. So I opened up a watch window. Okay, so this right here, these are the values of our array. Okay, so the first time we come in here, we're going to step through. Okay, so the first time it's just like when we just had the one loop, right? It's going to go through the list, and if any of the pairs are out of order, it's going to adjust the pairs. Okay, so watch the pairs as we go through. Okay, so see these pairs here, how they're slowly changing. So 7 and 1 switched. Oh, actually I went through too fast. So now 6 and 6 aren't going to switch. Okay, 7 and 2, did that switch? I didn't see. Where are we now? Oh, we're down here now. Okay, so every time it goes through, it's going to pass through the list once, and it's going to check all the pairs. Okay, then it's going to do the exact same thing again. Go through and check all the pairs, and again, and again, and again, and again, and again. Okay, so this is actually not a very efficient algorithm because it's doing a lot of things. It's doing a lot of wasted effort. It's doing things over and over. There are other algorithms that we can look at that are actually much, much faster. One is called quicksort, actually. So you see, after we've finished, so we've looped through 400 times. And every time we loop through, we've gone through and checked all the pairs. And so what ends up happening is all the low values end up bubbling up to the top. That's why this is called bubble sort. Okay, so if you have a value, let's say you have 0 at the lowest. Let's say we have 0 here. Okay, let's try looking through it again, and we can see it's going to be a little difficult to see, but what you should see is for every time the outer loop executes, the 0 should be moving up 1. Okay, let's try it again. Let's try running this. So here's our 0 at the bottom. Okay, so what I'm going to do, I'm just going to cycle through the inner loop all at once. Okay, so we're going to continue and then continue. So see how the 0 moved up? Now watch, I'm going to do it again. See how it's bubbling up? Bubble, right? Bubble. All the low values are bubbling up to the top. You see that? Well, all the big values are sort of floating to the bottom. And see, the reason it's an inefficient algorithm is because the algorithm's sorted now, but we still have, well, I guess we have one more to go through, so it's not too bad. Okay? But this algorithm can get very slow if you have a long list. Okay? Because it grows exponentially. Okay, so are you guys familiar with the difference between exponential and linear growth? So let me just give you a quick little example of the difference between linear and exponential growth. Okay, let's say I'm going to hire you guys to deliver newspapers. Okay, and one payment scheme, I'll start on so for 30 days, I want you to deliver papers every day. The first scheme, I'm going to pay you $1 to begin with on the first day. And every day after that, I'm going to add $1 to your pay. So in the next day, you'll be making $2. The next day, you'll be making $3, $4, $5, etc. The other scheme that I'll offer you is I'll pay you the first day. I'll pay you a penny, but then every day I'm going to double your wage. Which one of those would you pick? What's that? Yeah, so here, look at the Excel chart. So one is, so this is scheme 1, and this is scheme 2. So in scheme 1, you start with $1, and in scheme 2, you start with a penny. Okay? But in scheme 1, what I'm going to do is each day, I'm going to add $1. With scheme 2, what I'm going to do is each day, I'm going to multiply by 2. So which scheme do you guys want to take? The first one?
You mean only 30 days, right?
30 days. Only 30. The first one? Okay. Anyone else say, so
I would say
the same thing? Okay, let's try it.
I want the second one because it'll multiply until you reach a higher number.
Okay, let's see.
30 days,
Let's see. Okay, so day 3, okay. Your plan still looks good. You're making a lot more. I'm going to pick 2. I'm only making 8 cents. You're making $4. That's a lot. Now you're making $5. I'm still only making pennies.
That's the sum of the total, so...
Yeah, so let's do this. We'll do this at the end of 30 days. So I'll have sum, and we'll add up all of these. Okay? And same with this. So right now, you've made $21. I've only made 63 cents. So it seems like you made the right decision, right? But let's continue this trend. So you're making 7. I'm still only making $1. Are you guys sure you don't want to switch to linear? No, you're still, because you haven't even made, you've made $1.27. That's nothing, okay? But let's keep continuing. Oh, okay. So now you've made $5 and you've made 10. So 50. You've made almost 5 times the money. Linear seems the better option. Oh wait, but now, okay, now we're close. We're very close. Oh wait, it's only day 13. Now I still haven't caught up though. Let's see day 15. Oh, still, okay. You sure you don't want to switch yet? You're still making more. Day 14. Uh-oh, what happened here? Day 14. That's called the elbow of the curve. Okay, now what happens on day 15, 16, and 17? Uh-oh. Uh-oh. Oops. So let's go here, here, here. Oh. So I would have made 5.4 million, and you would have made $435.
Thank you.
Okay, so see the difference between linear and exponential. So when you're dealing with low numbers here, it doesn't really seem like there's that big of a difference, right? But as soon as what happens is you hit, it's called the elbow of the curve, then the growth really starts taking off. Okay, so that kind of growth, like let's say if you had a list with several hundred or 1,000 items, okay, that the time it takes to sort is exponential. So it's way bigger for 1,000 than it is for, say, 20 or 100. Okay, so when your algorithms are exponential in nature, you have to be really careful, because even though the computers are fast, things still take a finite amount of time. So even if it only takes 1 millisecond and you do something 1 billion times, that's going to take up a few minutes. Okay, so that's the difference.
I remember I did this Java program, and
Yeah.
it's a little off topic, but it still relates to searching. And
Yeah.
I was doing this algorithm search that showed the timing, right, in milliseconds.
Yeah.
And one time I did it around like 1 million items on the list, even though that search algorithm was fast, in the end it did not run. I don't know why it did not run. Sometimes it did not run in milliseconds, and sometimes it ran, but I don't know if it's a logic error, but there didn't seem to be any error.
Yeah, I'm not sure why that could be. There's lots of different
That's why I'm
reasons.
sometimes scared of software not running with that.
Yeah? Well, that's why we're developers. We can fix our errors, right? Okay, so that is a let's see, what else do I want to show you about arrays? Okay, so that being said, you can, if we comment this out, like I said, C# has built-in functions for this. Okay, I just did this just to illustrate some algorithms. Okay, but I could do this my array dot sort. Should have it. Do we not have? Oh, we have to use the class dot. So we use the class array, and then we use the function sort, and then we pass in our array. And we should have a sorted array afterwards. Let's see. I want to stop here. There we go. Okay. So C# gives you a lot of tools, but I want to show you how these things are done, so that you understand what's happening and that you start working with algorithms. Okay. Okay, let's look at some other methods, array methods. We can use array.reverse. So now if we sort the array and then we reverse it, and then also, so we don't have to debug anymore. Let's just print the values. So what we're going to do is we're going to do a for loop, and we'll say int I equals 0, while I is less than my array, dot length, I++, and then here we'll say text box 1 dot append text dot my array I to string go, and then we'll concatenate a new line string on there as well. So now when we reverse our array, whoops. So now it's in reverse order, from 9 to 0. Okay. There are a couple of other functions. Let's see what else is in array, the array class. So there are find. So we did a search algorithm already, but but there are find methods in C# as well. Okay, so that you don't have to do it on your own. Okay, there's also some binary search functions. So we could pass in our array, my array, and then we'll pass in, let's say, the value 5, and let's message box this value. So it's going to return an int. Okay. Negative 21. What is this? Binary search returns. Oops.
What is a binary search do?
So it's going to return it's going to search through the array and return a value depending on if it's in there or not. And so what it will do is it should return the index of your search. So let's see here. Why did it return 5? Because there is no 5. So let's try 8. Negative 21. What the heck? Let's try this. It's returning an int. Okay, so any questions so far about arrays and how we iterate through them? Right. So I hope you see how loops and arrays go hand in hand. Right. You'll very often use for loops and while loops to iterate through arrays. Okay. Let's see. I think that's pretty much all I wanted to show you about arrays. How to use them. Actually, okay, I'm going to show you one more thing before we end for this morning. So right now we've been working with one-dimensional arrays. Okay, so a list with just one column but multiple rows. but we can actually create multi-dimensional arrays. Okay, and the way we do that is it's pretty much the same. It's almost the same thing. So what we would do is we would say my array. So we'll say multi, and then what we have to do is we'll put a comma inside our square brackets. So this means that we're going to have 2 dimensions, one here and one here. Okay. So then what we can do is we can, so we're going to say it's a new integer, and we're going to give it, let's say, a 10 by 10 array. What's that? That is not how you do it. I think that's for Java. Let me just double check. Yep. So now what we can do, so now instead of a list, now we have a grid of data. Because now what we can do is we can say my multi-array, then we can say 0, 0. Okay, equals, let's say, 10. Okay? So this is saying on the 0th column and the 0th row, put 10. Okay? Then we could go on to the next row. So now we have it's like a grid. It looks more like this. So rather than this, just a list, we're going to have this, which is a table. So see how this is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, right? This would be 0, 3. What would this be? Yeah, or 4, 1. Okay, you get the idea. Okay? So now let's inspect this array and see what we have here. So see how we have we have the 0 row and then all these columns here as well. Okay, so really even it's a 10 by 10 multi-dimensional array. So that means how many indices, how many slots do we have in our array? How many? No, it would be 100. Why do you say 121? What's that? But it's 0 to 9. Yeah. Yeah, 100. Okay. So what would we have to use now? So before we used one for loop to process a single dimensional array. What would we have to do now to process a multi-dimensional array? 2 for loops, right? So let's say if we want to initialize this value, okay? We're going to initialize my multi-array. So I could do this. I could say for int I equals 0, while I is less than, we'll say my multi-array dot length. Do we have 2 options there? Length. Okay. I wonder if that's going to give us 10 or 100. So then we're going to increment by 1. Okay? And then inside the for loop, we're going to have another for loop. And we're going to say int j now. Okay? And we're going to give that a value of 0. And then we're going to say j is less than the length as well. Okay? j plus plus. Then in here, what I can say is I can say my multi-array I, comma j equals, and let's make it equal to I times j. Okay? Let's run that and see what happens. So let's inspect our array now. Oops. What happened here? Index out of bounds. Yeah, so I think it didn't like my length. So I'm going to have to do this. Okay? Unfortunately. So now if we look at our array, we can see all the values in here. See all the first values, because I is equal to 0. 0 times 0 is 0, right? So all the first ones are 0. Then in the second row, then we have all of these values. Then the third row, we have 2. Basically, they're multiples of integers. Okay. So if we go to add watch. So see this is the ones timetable, the twos timetable, the threes, the fours, and so on. Okay. So can you see how, because we have a multi-dimensional array, now instead of a list we have a table. Okay. Okay. So any questions about arrays? So we're you can see now we're sort of combining everything we've learned now. That's what, going forward now, that's pretty much what we're going to be doing. Nothing can really exist in isolation anymore. We're going to have to mix it all together. Okay? So that's where I'm going to end the lecture today.